Hi everyone. Today we'll be looking at two similar quadrilaterals. Can you guess them? If you guessed the parallelogram and the rhombus, you are correct. Both the parallelogram and the rhombus are flat geometric shapes having four sides with two pairs of opposite parallel sides. But what makes them different? Let's take a look at the properties of the rhombus and the parallelogram. So there are many differences between the rhombus and the parallelogram. The first property we'll look at are the sides of the rhombus and the parallelogram. So with the rhombus, all sides are congruent. This means that the rhombus has four equal sides. With the parallelogram, however, opposite sides are equal and adjacent sides are unequal. The second property is the diagonals. The diagonals of the rhombus bisect each other at 90 degrees and are equal. With the parallelogram, however, they bisect each other but not at 90 degrees. The perimeter. With the perimeter of the rhombus, it is given by perimeter is equals to 4 times the length of the side. With the parallelogram, it is given by 2 times A plus B, where A and B are the sides of the parallelogram. The fourth property is the area. The area of the rhombus is D1 times D2, all divided by 2, where D1 and D2 are the diagonal lengths of the rhombus. The parallelogram, however, has an area of base times the height, where the height must be perpendicular to the base. And the final property, the relation. A rhombus is a parallelogram since it satisfies all the properties a parallelogram exhibits. However, a parallelogram is not a rhombus as it does not satisfy the congruency of all its sides, which a rhombus does. Next, we will look at calculating the area of the rhombus and the parallelogram. As mentioned earlier, the formula for calculating the area of a parallelogram is given by area equals base times height, where the height must be perpendicular to the base. So, let's do an example. So recall the area of a parallelogram the area is equals to the base times the height. And in this example, we have a base of 8 meters and a height of 5 meters. So when we apply this to the formula, the area is now equals to the base, which is 8, times the height, which is 5. This gives the area of the parallelogram as 40 meters squared. Remember, area is always in units squared. We also looked at the area of the rhombus, which was D1 times D2, all divided by 2, where D1 and D2 are the lengths of the diagonal lines. Let's look at calculating an area of the rhombus. So with this rhombus, we have D1 and D2, where D1 is equals to 8 meters and D2 is equals to 7 meters. Recall the area is equals to D1 times D2, all divided by 2. Now we can apply our formula. So D1 is 8, D2 is 7, and we divide this by 2. So multiplying 8 and 7, we get 56. And we now divide this 56 by 2. The area is 28 meters squared. So in today's video, we looked at the two quadrilaterals, the parallelogram and the rhombus. We looked at their properties as well as calculating their areas. Stay tuned. Until next time, keep practicing.